Okay, so this is our balancing equation challenge in honors chemistry, and I'm just going to go over the basics of how we balance equations. So does everybody have the worksheet out in front of them right now? Okay, so we are going to count the atoms or ions on the reactant side and the product side, compare them, and decide if we need to add coefficients. The way we count, I've already listed for these first couple problems, but generally you would list the atoms or ions first. Second, you set them equal to the subscript. And if there is no subscript, it's a none. Or I'm sorry, if there's no subscript, it's a 1. So hydrogen has a subscript of 2, so we say H is equal to 2. Oxygen is equal to 2. On our reactant side of the equation, hydrogen is equal to 2 in our water molecule here, but our oxygen is only equal to 1. I start at the top of the list and I compare the two sides of the equation. If I have less on one side, I'm going to add a coefficient on that side. The coefficient is a number that goes in front of a formula and multiplies that formula. It tells me how much I have of that thing. So hydrogen is the same on both sides, reactants and products, but I have more oxygen here than I do here by a factor of 2. So I'm going to add a coefficient of 2 in front of my water molecule. Now that's going to multiply oxygen too, but you may already know that is part of the process and that we're going to correct for it on the reactant side. So I have to multiply everything in this water molecule. So hydrogen is times 2, oxygen is times 2. And now my oxygen is balanced, but my hydrogen is not. So I'm going to go back to this side. I'm going to add a coefficient in front of hydrogen here. That's going to multiply the hydrogen. I'm going to compare again, and now I have the same amount of hydrogen and oxygen on both sides of the equation. All right, very important. Do not forget to put the coefficient into the equation. That is what does the multiply. You can't just multiply anything that you want. All right, reaction type. So when we're looking at reaction type, we have 5 different kinds of reactions. Synthesis, we have 2 things, well, any number of things coming together to make one thing. So the key thing here is you'll have only one thing on the product side of the equation. In our decomposition reaction, it's the opposite situation. We have only one thing on our reactant side of the equation, breaking down to 2 or more things on the product side. In a single replacement, the key thing to look for is a compound and a single element. It can be a diatomic element, but will always be just a single element, not a compound. All right, and so what's going to happen is C is going to switch places with B in the compound. And that's what you see on this side. We have a new compound, AC, and B has traded places. And then in our double replacement, it's just like it sounds. Now instead of having just one thing swap places, we have 2 compounds, and the compounds are basically switching partners. Ionic compounds, binary ionic compounds are made up of 2 components, 2 ionic components, and those components are switching. So now instead of being paired with B, A is paired with C, right? So you can even figure it out. You can draw little brackets like this. A pairs with C, and B pairs with D. And that's what we see in a double replacement reaction. And then our last one is just really a unique pattern, combustion. For the combustion reactions we do, it will always be a carbon compound. That means, like for example, if we had methane, CH4 would be an example. And we will always have just oxygen gas on this side. All right, so a carbon compound plus oxygen gas. And our products will always include water, carbon dioxide, and the thing that we don't show usually in a chemical equation but is always there is energy. All right, any questions on that? So for this first reaction then, we see we have only one thing on the right side of the arrow. That means that this is a synthesis reaction. also known as a combination reaction. Okay, I'm going to go ahead and balance this equation too. So if we count this one, we've got 1 sodium, 2 bromines, 1 sodium and 1 bromine in a compound on this side. All right, so I'm going to compare. My sodium is balanced. My bromine is not. So I put a coefficient in front of the compound on that side. It has to go in front of the compound. It has to multiply everything in the compound. I can never change the subscript. That's going to multiply both the sodium and the bromine. And so now the bromine's good, but I go back over here and I have to fix the sodium. So I'm going to put a 2 in front of Na, and that is going to be times 2 here. And now my equation is balanced. All right. Once again, I have a combination or synthesis reaction. How do I know? Because I have one thing on the product side, a compound. So this is going to be labeled synthesis again.